Example number 3. Use the given information to find the exact value of A, sine 2 theta, B, cosine 2 theta, and C, tangent 2 theta. Given, cosine theta is 12 over 13, and theta lies in quadrant 4. So first of all, let's look at sines. We're looking at the fourth quadrant, and down here, cosine is positive and sine is negative, meaning tan is also going to be negative. So I've written in the formulas that I'm going to use. So the sine of 2 theta is 2 sine theta cosine theta. Cosine of 2 theta is cosine square theta minus sine square theta. I usually just stick with that one. However, when we're doing identities, we may need some of the others. Tan 2 theta is 2 tan theta over 1 minus tan square theta. So sine 2 theta. Well, we have to find our missing side first. So I'm just going to sketch a little triangle here. And I'm going to label what I know. If theta is here, and the cosine is 12 over 13, I know the adjacent side and the hypotenuse, but I don't know the other side. So I'm going to use the Pythagorean theorem. 12 squared plus b squared equals 13 squared. So 144 plus b squared is 169. So subtracting 144 from both sides, I get b squared is 25, means b is 5. So my opposite side is a 5. So now I'll find my sine of theta. I already know my cosine theta. It's 12 over 13. And then I'll find my tan theta as well. Now remember, we're looking at a sine that is minus and a tangent that is minus. So I'll go ahead and put those signs in. So the sine's going to be the opposite over the hypotenuse, and it's going to be negative 5 over 13. That's going to make my tangent negative 5 over 12, opposite over adjacent. So now I can use the formulas to find the answers. First is sine 2 theta. That's 2 sine theta cosine theta. So 2 sine theta negative 5 over 13. Cosine theta 12 over 13. And you can do it manually, or you can use your calculator using the fraction key. I'll just go ahead and multiply all the numerators and the denominators. So 2 times negative 5 is negative 10 times 12 is negative 120. And 1 times 13 is 169. So the sine of 2 theta is negative 120 over 169. So now I'll do cosine 2 theta using cosine square theta minus sine square theta. So 12 over 13 squared minus negative 5 over 13 squared. 144 divided by 169 minus, and remember we have to apply this exponent first before the subtraction. So that's just going to be a positive 25 over 169. And when I subtract that, I get 119 over 169. So cosine 2 theta is 119 over 169. The last one, tangent 2 theta. So tangent 2 theta has a formula that's a fraction. It's 2 times the tangent of theta, which is negative 5/12. All of that is over 1 minus tan square theta. So in my numerator, remember this 2 is over a 1, is negative 10 over 12. So in my denominator, 1 minus, and again, this sign gets squared first, so this is going to stay as a minus sign. 25 over 144. So I'm going to need 144s for all of my denominators. So I'm going to multiply top and bottom of this by 12, top and bottom of this by 144 over 144, okay? Now, I don't have to multiply that last fraction because, look, we're just multiplying these fractions by 1, and we're not changing the actual value of anything because we're multiplying by 1. We're just changing the format of those two. So I've got negative 120 over 144, and down here I've got 144 over 144 minus 25 over 144. I'm not going to reduce anything yet. Negative 120 over 144, and that's going to be over, and that in my denominator I have 144 minus 25, which is 119. That's over 144. And since we would have to flip, these 144s would cancel out. And we will get, for our tan 2 theta, negative 120 over 119. So my final answer for the tangent of 2 theta is negative 120 over 119.